Okay, we are going to discuss the tensile failure, right? The tensile failure means it involves progression of microstructural damage and starting with matrix cracking and potentially leading to fiber fracture and failure. Okay, and the specific failure mechanism depends upon the fiber matrix interface strength and with strong interfaces leading to brittle fracture and weak interfacing allowing for more ductile behavior through mechanisms like fiber bridging and debonding. Okay, these are the possible reasons to the tensile failure, right? And then compressive failure, right? It involves the fiber buckling and delamination and debonding due to the compressive stress acting on the materials, particularly in situation like fatigue testing. Okay, in this, if the fiber alignment is poor or structure in thin walled, with this type of compressive failure will the possible. Okay, and the flexural failure. Okay. Next, we are going to see the flexural failure. It involves multi-stage, including matrix cracking and interfacial debonding and eventually fiber fracture. Okay. It will happen in this failure. Okay. And the initial failure often starts on the tensile side of the specimen, and the process is influenced by factor like perform structure and loading direction. Okay, mainly it's arising the combination of tension and compression. Okay, this is the main reason for flexural failure. Okay, and then we are going to discuss the shear failure. Okay, in this failure due to sliding at the fiber matrix interface or delamination between layers in multiply composites. Okay, inclined crack or interlaminar delamination surface are also the possible for shear failures. Okay, and then one more failure is available, delamination. Okay, the delamination means the separation of layers within a composite material, typically due to mechanical or thermal stressor. Okay, these are the possible ways. Okay, and this phenomenon can significantly reduce the strength and stiffness of the composites. Okay, separation between composite layer due to weak bonding or out of plane stresses. These are the possible reasons for delaminations. Okay, and then one more failure is possible by the thermal shock. Okay, here what will happen? The surface cracks, shipping, or layer flaking, especially is coating in thin components. Okay, and the main failure progression is often localized at first, then spread under the continued thermal cycling. Okay, and final one is the environmental effects. The oxidation and corrosion is the main reason uh, for this failure, right? Uh, then we are going to discuss standardized testing methods, right? Here we have five types for testing. Okay, first one is tensile testing, second one is flexure testing, and then shear testing, fatigue testing, creep testing. Okay, these are the various types of testing, standardized testing method, right? In tensile testing, we can measure ultimate tensile strength and strain to failure, right? And in compressive strength, we can evaluate crushing or compressive load capacity and as in shear strength, in plane or interlaminar shear testing, and fracture in fracture toughness, measures resistance to crack growth, and in creep testing time dependent deformation at high temperature, and in fatigue testing we can do the cyclic loading to assess entrance and damage accumulations. Okay, these are the standardized testing methods, right? Next, we are going to discuss the factors influencing failures. We can see in that next session.